however many points you want, and then just put if it doesn't equal 3 points, run an error message for that particular program. But then you can just adjust that for future programs. Yeah.
All right, so last time, we'll pick it up right where we left off last time. We were trying to process this book data, the CSV data, and then we initially created this book class because what we had was 9 pieces of data. A book ID, title, all that stuff, and then we collected it, encapsulated it into one unit so that when we run a report and we want to know what's the best book, what's the worst book, what's the newest book, what's the oldest book, right? We can answer those questions much easier if we have the concept of a book. If we have a object, in this case a class, that represents a book, okay? Now, before we start using this, I'm going to very, very briefly go through good object-oriented programming best practices. We're going to talk about this again later on, but basically, what I've got now is a bunch of public data, right? What I can do over here in the book demo class is I can create a new book, and then I can say book.title is equal to foo, right? Now, that seems like it should be okay, straightforward at first, but no. The idea of encapsulation consists of actually 3 things. It consists of the grouping of data, which we've done, and 9 pieces of data into one logical unit, a book, but also consists of protection of that data. What would happen if somebody was just able to set this equal to null? That would be kind of bad data because we have a book with no title. We have a book with no ISBN, right? I don't want to allow that. So what I'm going to do is I'm going to shut off access to the outside world by making all of these variables private. Now that's what you should do. By default, every variable should be private unless there's a very good reason to do otherwise. Did you see my magic trick there too? Right. So Option Command A gets you, this is a Mac, so Option Command A gets you back and forth through what's called block selection mode. This is the mode that you're used to right here, where you select multiple lines. Well, what you can do is you can actually select multiple columns and lines, only that block for it, right? And then you can also select a column here, and then just start typing, and it'll do it on the same line. You can also delete on the same line. So it saves you some typing there if you ever need to do something like that, okay? And again, it's Option Command A, it's probably Alt Control A in Windows or something, right? Now what happens over here is that I can no longer set the title to whatever I want, okay? So what we need over here is the basic CRUD, create, retrieve, update, and destroy, right? I've already taken away update because I've made these things private. I'll show you how to restore it, but you shouldn't do it. We need to now focus on the create. How do we actually create a book over here with a title? Because if I don't if I provided a title over here, then I can't change it later on, right? So the first step is to create what's called a constructor. A constructor is a very special method that is named after the class that you are constructing. I'm going to make it public because I want my code to see it. It is named after the book, but unlike the other methods that we've seen so far, is there a return type here? Is it returning void? Or is it returning double? Nope. It's returning what? Implicitly. It's going to create a book and give it back to you, right? So there is no return type here because the function is named after the class, and therefore it's a constructor. Now I want this constructor to take all of these pieces of data. I want it to take a book ID, I want it to take a author, string author, etc., etc., etc. I don't like typing, so I'm going to show you another shortcut here in a second. Let's just type out the first 2 though. This dot book, actually, sorry. Before I introduce the keyword this, let me go ahead and say book ID is equal to book ID, right? And author is equal to author. Now both of these are going to be highlighted as a warning. Let me read that warning to you. The assignment to a variable book ID has no effect. Let's go back to C, right? In fact, this is in any language. Int x is equal to 42. Fine. X is equal to x. Would you ever write a piece of code like that? It's nonsense. What is it doing? taking the value of x and putting it right back into x. And that's why it's warning me that the assignment to variable a has no effect. Right? Same thing here. Right? I am assigning book ID, this book ID right here, the parameter variable, back to itself. There are actually two book IDs here. There's the parameter variable, and then there's this object's book ID up here. There are two separate variables with the same name. Right? That's not bad practice, right? That's usual practice. But what we need to do is we need to disambiguate it by saying this book's ID is equal to that book ID, right? If you want to talk about it, that book ID, right? It should be ID. There we go. There we go, and there we go, right? So I'm setting I'm the book now. I'm inside the book class, and I need to set my book ID to that book ID that you just gave me, right? But I'm not going to call it that book ID. I'm going to call it book ID, right? Yeah.
So this that book ID is referencing that
Yep.
integer book ID.
Exactly.
Setting it to the outside parameter.
Exactly. If I click on it, it takes me right there to that book ID, right? As part of the class. Yeah.
So this just references the main class themselves?
This is representing me, myself, and I. I'm a book, right? It's a way, no, this is an object, so we don't use me, myself, and I. Instead, we use this. And in fact, over here, what is the name of this book? B. Right? What is the name of the book when I jump inside the book? There's no, you don't refer to yourself as Jack, or I don't refer to myself as Chris or something, right? We'd be speaking in the third person. We say me, myself, and I. But it's an object, so how does it refer to itself? This, right? Yeah.
So you made all those variables private. So I have two questions. One is, can you explain again why you did that? And two, it seems like this code under it sees it, but private would mean that code outside of this class would not see it.
Bingo, exactly. It's inside the class, I can see myself. I can see my own data. I can see my own hands, right? But outside the class, we can no longer see that stuff. B.title is equal to foo, right? It's protecting that book's data, right? If it was not private, if it was public, anybody could change it. And if anybody could change it, like you could change pi, right? You could change all these other things that you don't want to change.
So if it was public and you did B.title equals foo, that changes the class.
If I change it to public.
Yeah,
Yep. Now, yeah, you can go ahead and change your title to foo if you want to.
of all of the class.
Of that instance of that book B. I'll call this B1 because you can have multiple books. B1 and B2. There we go. Now, this has changed book 1's title, but this has changed book 2's title. Right? They have two completely separate titles.
Don't you want that?
Yeah, well, I want to be able to have two different books. In fact, I'm going to want like 30, 40 different books. But I don't want the outside world to change this stuff, right? Because I like immutability, right?
Because they're the functions based on the inputs.
I'm protecting this data, right? Once I've created this book, the title, the author, the ISBN, I don't want that to change. Because you could change it to null, and now I've lost information, right? Yeah. So, again, I don't like typing, right? And I've only done 2 of the variables. I need to type out 7 more variables here. Let me show you a shortcut. Go up to source, generate constructor using fields. Now you can select or deselect any fields that you want. I'm going to select them all because that's what I want, right? There. And it auto-generates that code for me. Ignore that line for now. We'll come back to that much later. Okay? So I didn't have to type the other 7 things. In fact, I didn't have to type the first 2. Right? It did it all for me because this is code generation. Okay? Now let me come over here to the book demo, and I can no longer create just any old book. I now need to give it a title. I need to give it a author. I need to give it et cetera, et cetera, et cetera. So let's do that down here when we're processing this file. Remember this CSV file? I'll drag it over here. We've got a whole, like Nick Offerman's Paddle Your Own Canoe, One Man's Fundamentals for Delicious Living, Let's see, and that's going to be the first name and last name, I think, are swapped. That was something I needed to fix. Nick Offerman, there's the ISBN, there's the rating, that's the publisher, and then there's the original publication year, and there's the date that I read it. Okay? So I want to process all this book data here. Recall that what we're doing is we're opening up this file, the CSV file. I am wasting the first line because there's that header data there, right? That looks like this. Then I'm going through each line, grabbing that line, and as long as it's not empty, because remember in that file, we could have a bunch of empty lines at the bottom with no data in it, right? So I'll save that and get rid of it. Only if it's not empty. If it is not empty, right? Then we split it out into the tokens, okay? And before we were only doing the rating, but now I need to do all of them. So int book ID is equal to integer.parseInt of tokens of 0. Remember that that's the first token right there. The second token is going to be the title, is equal to tokens of 1. I don't need to convert that because it's already a string. All right. The next token is the first name and the last name. Remember, I had to fix that, last and first. So I need an author there. That's going to be a person, is equal to new person with that first name, tokens of 2 and tokens of 3. And that's the author, right? There we go. Uh-oh. Do I have a constructor in the person class that does something like that for me? Let me go and check. Nope, I have the same problems here as before. So once again, let's go ahead and make those private. And do you want to type? Or do you want to go up to source, generate constructor using fields, and generate those two? There you go. All right, reformat it, all good. And now over here in my book demo class, now I can create it with the first name and the last name, okay? Now we're up to the ISBN. That also is a string. ISBN is equal to tokens of 4. Right, that's the 5th token. The average rating, I already did that last week where we parse out the 6th token at index 5. Right? The publisher, I'll make that into a string. Publisher is equal to tokens of 6. And then the original publication year, we said that was going to be an integer. So publication year is equal to integer.parseInt tokens. Now we're up to 7, right? Right? Is that right? Yeah, that's right. And then we're all the way to date read now, right? The date that I read it, okay? Now this is a little bit different. I'm going to actually get rid of these for a second here, right? This one is a little bit different because remember that we were modeling this. How are we modeling a date? Well, you could do it with a string, an ISO 8601 string. Right? In fact, for your assignment, I would suggest that you do that, right? The third part, just use an ISO 8601 string because that's what they are, right? Aren't they? Yeah, I think they are. Otherwise, you could always use local date if you really wanted to, but then you can't use the functions we gave you to calculate like the running time between data points. But anyway, local date here does it using 3 numbers, remember? Here we go. An integer for the year, a short integer, which is a 16-byte integer for the month, and then a short integer for the day. Now, if you're coming from a C background, you might think that you can actually use a byte, B-Y-T-E, and you can. Don't ask me why they use shorts instead. Right? Probably because bytes cannot be treated as unsigned integers, or assigned integers, I'm not sure. You only need 8 bits, right, to represent 0 to 31, right, or 1 to 31. But because we chose to use local date, we actually need to use something else, something different here. Local date, date read, is equal to local date dot of, right? Actually, that's one way of doing it. The year, like 2024, 1/1. That would be January 1st, 2024. But I'm actually reading it from a string, right? Which it looks something like this. Let me go ahead and open that up again. And let's go to the bottom there. So it's going to be the Americanized version of month, day, year. There is a function to do that. We'll find out that it actually doesn't work. But local date dot parse tokens sub 8, right? We'll see why that doesn't work here in a moment, okay? But once I've got those 9 pieces of data, 2 of them are encapsulated into another class, person class. But once I've got all those pieces of data, I can create now a book, and I'll just call it B, is equal to new book, and I'll pass in each one of those pieces of data. Book, ID, title, author, ISBN, rating, publisher, publication year, date read. There. Okay? If you want more real estate, I can zoom out a little bit. There we go. But otherwise, you're stuck with long lines. If you really want to, you can break these lines up. Generally, what you would do is you would align them like this. All right? But I find that's kind of unnecessary. It's not that long of a line. Right? Okay? Now that I've got my book, right, I can print it out. System.out.println B. Right? Now, 2 things are going to go wrong here. The first thing that's going to go wrong is that it's not going to be able to parse out that Americanized version of it because it doesn't understand the American way of writing dates. It wouldn't work if it was European either. It would work if you use the ISO 8601 standard. Right? 2024, zeros in the front and hyphens, I think is what's required, and then 01-01. What you can do is you can create what's called a formatter, right, to like an Americanized formatter, and then use that, and then pass that in with a parser here. I don't want to do that though, because that's asking too much for just this demo. So what I'm going to do is I'm actually going to ignore the date that I read it. Okay. That means that we can't compile there. Right? So one option is to pass in null. I don't know what date I read it. I'm just going to go ahead and leave it null. It's kind of messy because now you're passing in explicitly null to a constructor just to ignore it. I would prefer to be able to have a constructor that looked like that, where I had the option of providing the date that I read it or the date of not providing that. Right? So let's come back over here to book. You can have as many constructors as you want for your convenience. I'm going to go ahead and generate a constructor using the fields, but I'm not going to select date read. Right? That generates another constructor. Now I've got 2 constructors. One that takes all pieces of those data, one that takes all the pieces of the data except for the date read. Right? And implicitly what's happening here is that this date read ends up being null. Right? I don't have to explicitly write it like that, but that's what ends up happening. Okay? All right, now this compiles over here. Before we could take a look at that though, I hate repeated code. And I hope that you hate it too, because it violates the DRY principle. Don't repeat yourself. Right? That's the DRY principle. I've got a lot of repeated code here and here. And once again, I'll go ahead and get rid of that super and just ignore that for now. Right? So here's a way to cut down on that code. This is more general because it takes more data. This is more specific because it takes less data. So I will have the more specific constructor call the more general constructor. And how do I call that constructor over there? Book, passing in the book ID, title, author, ISBN, rating, what else is there? Publisher, publication year, and finally null explicitly for the date read. Right? I'm passing in null for this date read up here. It doesn't work like that though. So objects use pronouns here. What's my pronoun as an object? This. It can also be a function call. This implicitly calls this constructor up here. In fact, I'll show you that if you click on this, it takes you right there to that explicit constructor up there. Yeah. Compilers are dumb, but at least they can count. Right? It counts up, oh, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, or whatever, 8 or whatever there are. And also, this one is an integer, that matches. This one is a string, that matches. So the compiler can suss that out. Because if I did something else, like say, hello, Now the compiler says, wait, that's not an integer. I don't see a constructor that takes a string as its first argument. So compiler error. Right?
So the more specific would always,
More specific always calls the more general. Right? Okay. All right, so we fixed that first issue, and I told you that there were going to be two issues. Let's now witness the second issue here. Do those look like books to you? There's the output. UNO ECE, that's the package name that we're in, right? Then book, that's the class that we're trying to output. But then what the heck is this thing right here? It's hexadecimal, right? Have you seen hexadecimal before in your C class? When you print out a memory address? And that's what that is, right? So let's go back over to our book and remember the CRUD: create, retrieve, update, and destroy. I've given you two ways to create a book, right? I haven't given you any way to retrieve the information. So I'm going to do that in two ways now. What if you just wanted one piece of data? What if you just wanted the title, right? Yes, ignore Microsoft Teams, please. There we go. I just want the title. Public, get a string, get title. Right? Return this dot title. Right? Now that's called a getter. I want the title so I can print the title out. Let's do that over here. Instead of printing the book, I'll say get title. Right? Now I've got all the titles. There we go. Paddle your own canoe, killing commendatore, the moon is a harsh mistress, etc., etc. Let's come back over here. But what if you want the other ones? What if you want the author? What if you want that? What if you want that? Once again, I hate typing, and I hope you do too. Let's come over here to the source, generate getters and setters. Right? I'm going to select all the getters and show you what that looks like. There. Get book ID, get title, get author, get ISBN, etc., etc., etc. Right? Didn't have to type a single thing. Let me show you, just briefly here, the U. Remember, CRUD, create, retrieve, update. So that's what's called a setter. Let's go ahead and generate a setter here. Let's go ahead and say the publisher here. Right, there, highlight the set publisher. What does it look like? It's a void function because it doesn't return anything. But instead of getting, you give it a publisher, and then you set this publisher equal to the publisher that you were just given, just like the constructor. Right? You can do that if you really want to, but you should prefer immutable objects because of thread safety. Strings are immutable. Remember that you create hello with a lowercase h, and you screwed up and you want that as an uppercase h. You have to call a completely different, you have to call a function that creates a brand new string, because once you've created that string, you cannot change it. It's immutable. That's a very good thing, because it means that if I've got a book, one thread can't come in and change the data while another thread is reading it. Right? They're not stepping on each other's toes. If you've never heard of a thread before, we're talking about multi-threaded programming. Right? We're talking about my Mac here, I think has, don't quote me, but I think it has 8 cores. And then with hyper-threading, it can do 16. We can check it really quick. HTOP, nope, top. Let's see, 85% of it's idle. I don't know if I'm going to be able, without HTOP, I'm not going to be able to determine how many cores I have. But there is a command that you can use to find out. I just forget it off the top of my head. But in any case, I've got a lot of cores, right? 8 cores, maybe 16 with hyper-threading. That means that 16 things can run at once on my machine right here. You go to one of those supercomputers down the hall, and you're talking about hundreds of cores, right? And each one is a thread. Well, you want to generally program thread-safe programs so that that one core is operating on this data, another core is operating on this data using a thread, and they don't step on each other's toes. Read-only data gets you that for free. Right? This ends up being read-only data. If you want to create another book with different values, call the constructor. Right? Create a completely different copy. Okay. The second way that I'm going to do retrieve, remember, create, retrieve, update, and destroy. By the way, there is no destroy in Java because it's memory management. Right? It takes care of the cleanup for you. You don't have to call malloc. You don't have to call free. There is no destroy. Right? So the other way of retrieving something is to create what's called a toString method. And I'll just make it look like this. That's what the default is. Let's come back over here and see what it looks like. It's not going to look pretty, but it's going to look like something, right? Book ID is equal to, title is equal to, author is equal to, et cetera, et cetera. Oh, uh-oh. What does that tell me about the author class? I also need a toString method on that one. I'll come back to that here in a second. Let's make this look pretty though, okay? I don't want all of that stuff. I just want, say, the title. So string.format. This is like, did you ever use sprintf? It's printf, but instead of to the standard output, it's printing to a string, right? So this is basically that, string.format. And now I can put in printf style formatting here. I want the title, which is a string, by an author, which is also a string. And I'll put into parentheses here the rating, right? And then the year, %D for the year, right? So this will be the author, or sorry, the title, the author, the rating, and the year. And I don't care about that other stuff. If you care about that other stuff, then write your own toString method, okay? All right, so this will be this dot title, this dot author, this dot rating, this dot year, publication year. Code complete there, code completion for me there. That looks much better. Right? We're still not perfect, but it looks much better. Paddle your own canoe, one man's fundamentals for delicious living by UNO, CSE, ECE, blah, blah, blah. There's the rating and there's the year. We're almost there. Who is it by again? Nick Offerman. But because I don't have a toString method over here in the person class, that it's giving me that weird memory address stuff. So once again, let's go ahead and generate getters and setters. Just the getters though, because we like immutable objects. Right? Let's go ahead and generate the toString method. Right? And instead of that stuff, I want last name, comma, space, first name. And you'll note here that there is no this that I've been using, but it's best to do that, right? The code generator does not, knows that you don't have to put this in this case, but it's still best practice to do so, in my opinion. But anyway, come back over here. Now we've got that guy, Offerman, comma, Nick. We've got Murakami, Haruki Murakami, right? We've got Frank L. Baum, right? Right, the Wizard of Oz series, et cetera, right? And then Harry Harrison right there as the last one, okay? All right, so let's get rid of rating, let's get rid of that, and let's get rid of, where's my ratings there, okay? Actually, no, let's highlight this. Before, we were just keeping track of the ratings. Now that I've gone through all the trouble to design a book class, to design a person class, now I'm not restricted to just the ratings. I can keep track of all the data on all the books, right, with a list of books. Now remember when we started at the beginning, in computer science 1, you do top-down solutions. You take a problem and you chop it up into smaller and smaller bits until you immediately solve those bits. I said that this is going to be the opposite, that we start at the bottom. We start asking questions of, well, how do I model a book? Here's a book class. How do I, oh wait, a book has an author. How do I model an author? I've got a person class. Now that I've got my building blocks, I'm going to work upwards, right? Not ratings, but books, okay? And then I can say system.out.println books. But to do that, instead of printing them, I need to add them to that collection, books.add b, right? And now I've solved the problem of loading up all of the books into one big list, okay? I've got all the data. It's all nicely encapsulated into each book, right? It's all separated out. At this point, I'm going to take that entire code and move it, right? Because you want good code organization. I'm going to create a public static book list, or list of books, sorry. List of books, load book data, or load books, let's just say, right? And that's where I'm going to put the code, right? so that my main looks nice and pretty and small, right? So I'm going to return books. Now down here, list of books is equal to book demo dot load books, and now I've got my books here. That's what your main should look like, right? It should be just a series of function calls because your main should be small, and this function now is reusable somewhere else. In fact, you can make this more general by taking this out and putting in a file path here, string file path, right? File path, oops, I don't want to, there we go, file path, right? And there, I'll load it up from there. Why would I want to do that? Especially with your homework. In that third exercise, you're loading up 2 files, right? Are you going to copy, paste, load from file A, load from file B? Are you going to copy, paste that and have 2 copies? Violation of the DRY principle. What are you going to do? You're going to take that and put it into a function, right? Just like I just did. Right? And then you can load books A and load books B if you want to, if you've got 2 different copies of it. Right? All right. Once again, we're still good. We're still good here. Test as you go along. But now I want to go back to my questions. Right? 1, what is the best, worst book? Right. 2, what is the oldest, newest book? Right. 3, find a or all books by Haruki Murakami. Right. So, with the rest of our time, we will now answer these questions, which is going to be a hell of a lot easier now that we've got the building blocks, the book class, the author class, etc. Okay? So, let's take the easiest one first, the best and the worst book. What would you do? Yeah.
Take the rating and then sort them.
Ah, sort them by the rating? Okay, I like that idea. Sort by rating. That means we have to understand how we sort. Right? So I'm going to jump all the way down here, and I'm going to give you a quick primer on sorting. Okay, how do you sort in Java? Let's go ahead and create a list of integers, right? Numbers is equal to, I'm going to have to go arrays.asList 5, 3, 8, 2, 9, 1, 0, 5, 6. Right? Okay. Now is that sorted? Nope. In fact, if I output that numbers, then you'll see that it's not sorted. Right? 5, 3, 8, et cetera, et cetera. Right? So how do you sort? It's easy enough. Collections.sort. Collections.sort. Numbers. Let me show you that it has now been sorted. It does the work for you. What sorting algorithms did you look at in CS1? Any of them? Did you at least use QSort in the standard library? No? Okay. Q stands for quick sort, and that's how you would do it in C, right? Okay, so then that means you also didn't look at binary search in CS1. Okay, all right. So then we'll do a review. We'll do an introduction here. What sorting algorithm is actually going on under the hood here? It's called TimSort. It's named after Tim Peters, right? Tim Peters is one of the, not the inventor of Python, but one of its contributors. He came up with a sorting algorithm and integrated it in Python, and it picked up, and other languages have adopted it since then. And he didn't name it. He didn't call it out, like name it after himself. Other people said, "Oh, Tim Peters made it, so we'll call it TimSort," right? But anyway, there's a TimSort algorithm going on over there. Is it documented? Let's see. Here's the documentation. It's not telling you what it is. Find Tim. Tim. Nope. Tim. Find Tim with a space. Okay, it's not in there anywhere. It's somewhere down inside there that you'd have to find it. Anyway, that's how you can sort numbers. But I don't want that one, right? I don't want that ascending order. What's another way that you could sort numbers? What's the opposite? Descending order. So let's go ahead and sort it in descending. Like the default here, the default is the natural order, which is ascending. Right? I want to sort descending. Did I misspell natural? Natural. There we go. Right. To do that, I need another component. This sorting algorithm knows how to sort. In other words, if it knows, okay, well, this thing comes before this thing, so I leave it alone. Or this thing comes before this thing, so they're out of order, so I'm going to swap them. Right? It knows how to do that. It just doesn't know what these things are. Right? So what we're going to do is we're going to tell it what these things are using what's called a comparator. Right? Given A and B, this is going to return, which are integers, right? And I'll call this CMP int descending because that's what it is. It's a comparator for integers in descending order. New comparator, right? And this is going to be new syntax for us here. That's all right. Let me go ahead and import this because it is in the java.util library. Right? And this is what's called an anonymous inline class, right? What I could have done is I could have taken this method and put it into another class called my awesome comparator for integers in descending order. Very, very long name. We don't like long names. We don't like names if we can get away with it. And this is why it's an anonymous class. It has no name, right? Because it's not in another class. The variable has a name, CMP int descending, but that's the variable name, not the class name. Remember that it is a comparator, and then we use Langle-Wrangle because this is a comparator for integers. Yeah?
So in my program that I'm writing, I have something that could belong to another class, but really I want to make it just like its own standalone thing. How would you do that?
Pretty much like how we did this. Make it static. Like, it depends on what you mean by the thing. If you mean a function, if you want a function by itself, then make it static and put it somewhere. This could be the same class.
Like oh, it just put the same class.
It could be, yeah. I mean, if this were more complicated, I would put it into a utils class or something, right? Yeah. Right. All right, so again, the syntax. Comparator, Langle-Wrangle, it's a comparator for integers. Right? You repeat that over here, but instead of a semicolon, right, you have an opening curly bracket and a closing curly bracket, then a semicolon. Because inside those curly brackets, we're going to define this function called compare. It returns an integer, and it takes an integer A and B. The auto-generated code likes to call them O1 and O2, object 1, object 2. I like to call them A and B. Right? And the idea here is that if A is less than B, then we will return something negative. Right? Else if A is greater than B, then we'll return something positive. Else 0, return 0. And now we can get rid of this auto-generated code. That's no different from this up here. But that is that's the pattern of a comparator. Given A and B, if they're in order, A comes before B, it returns something negative. Think of it as the number line. Here's 0, here's the negative values, A and B. Here's the positive values. Right? If they are equal, then we're right on the y-axis there at x equals 0. It's going to return something 0. Otherwise, if they're out of order, then we return something positive. Now, if I were to use this comparator right now, in that sort function, numbers, CMP int descending, I'm not going to see any difference because of the ordering that I gave this. That's the same natural ordering. How would I flip that so that it's reversed? Right? How would you flip this so that it's positive? Positive 1. How would you flip this so that it's negative? Negative 1. Equals, right, is, okay, so let's go ahead and negate 0. Does that make any sense? No, so don't do that. Right? And by the way, you can type positive 1, don't do that. It's ugly. But by reversing it, now I've got it in descending order. All I had to do was define a special comparator for it. Let me show you one more example. A list of strings. Names is equal to arrays.asList, Chris, Grace, Zoe, lowercase Chris, Chris with a K, and then with lowercase, and then Grace with a lowercase g. Right? Now, if I just sort these, well, here, actually, let me grab this. What if I tried to sort names with CMP int descending? Is it compiling right now? This is a list of strings. What is this comparator for again? Integers. It will prevent me from doing that. All right, so let's get rid of that. What's the natural ordering of strings? Chris, Grace, Zoe, Chris, Grace, Chris. Does that look right? I mean, it looks right for lexicographic order. All uppercase letters come before all lowercase letters. What I want, though, is I want to ignore the casing so that the two Chris's are together, the two Graces are together, and small k Chris comes before Z Zoe. So once again, let's go ahead and create a comparator for strings. CMP ignore case, right, is equal to new comparator, right, for strings, and then opening curly bracket, closing curly bracket. Again, I'm going to add an unimplemented method here. I'm just going to let it do it. By the way, if you're wondering what that is, we'll talk about that later. It's an annotation. It's aspect-oriented programming. Right? But otherwise, we're given two strings now, A and B. Right? Okay? I need to compare those. I don't want to write my own comparison function, so I'll reuse one. A dot compare to another string B. Right? Now, if I did that, or return, sorry, because that return, it follows the same exact pattern, something negative, positive, or zero, depending on the relative ordering of those two things. Now, if I use that, I have the same problem here of it being case sensitive. Right? Same as before. So instead of using compare to, there's another version of it called compare to ignore case. And when I use that inside of my comparator, there we go. The two Chris's are together, the two Graces are together, Chris is before Zoe. Right? There is two use cases where you would want to use comparators. I'm going to go ahead and put that into the notes so that you have it by itself. Come on. Searching and sorting. We'll come back to it because we also need to talk about searching. There we go. All right. So that's all in the notes there. So now back to you. Yeah, go ahead.
Could we also have access to like your book class and person class?
That's what we're going to do now, right? So you wanted to sort books. Sort books by rating, right? So step one, create a comparator. Comparator. Comparator for what? Integers? Strings? Doubles? What are we comparing? That book is better than that book. We're comparing books. CMP book by rating is what I'll call this, right? Is equal to new comparator for books, opening, closing curly brackets, semicolon there. Go ahead and let it generate as much code as it can. Right? And now what we need to do is we need to compare book A to book B. Oops. Book B. Let me write the logic really quick. If A dot get rating, remember that we wrote those getters for a reason? Now we want the ratings out of it. If that's less than B dot get rating, are they in order or out of order? So this is another question. What order do you want to go in? Where do you want your best book? Do you want the best books up here and the worst books down here, or the worst books up here and the best books down here? Which one? Best on top? All right. So that means that A is less, so it should go down, right? So we should return what? Something positive, right? Because they are out of order. Right. B comes before A because it has a higher rating, right? Else if A dot get rating is greater than B dot get rating, I always like to go A, B, no matter what, and just flip this guy right here, right? They're in order, so return something negative. In order, because A's rating is better, okay? What if they have the exact same rating? Return what? 0. No change. No, don't swap them, right, to the sorting algorithm. So collections.sort. Now I'm going to sort the books using that comparator there. And now let's, actually, one big giant long line is not gonna look pretty. So let's go ahead and go with a traditional, an enhanced for loop here. For book B in the collection books, give yourself a space there, system.out.println B. There's all the books. Is the best book at the top? 4.38, 4.929, 4.919, 4.15, dot, dot, dot. Is the worst book down here at the bottom? Looks like it to me. Okay. I'm going to keep this, but I'm going to show you now an even easier way of doing that. Okay. Comparator dot, comparator for book. I'm going to steal the same variable name there. Right, is equal to comparator, you got to spell it right, dot comparing. I'm going to compare a book by its rating, get rating. Right? That exact, not the exact, but that basic logic there is all encapsulated in that one line. New syntax. This is called a method selector operator. In the book class, use this function for your comparison. That's what it's basically saying. This comes from C++, I want to say, and C++ stole it from somebody else, so I don't know where it was originally. But that's used in C++. It's a method selector operator. Let me run that again and see if we get the same results. Is the best book still at the top? No, because it's the natural ordering. It's in ascending order. That's okay, because what you can say is reversed. Right? And now, run it one more time. Once again, is the best book at the top? Thud, Terry Pratchett. Is the worst book at the bottom? Yep. Which syntax do you prefer? The easier one, right? That's way better. All right. So to answer the question, what's the best book, what's the worst book, you would simply get the book, best book is equal to books dot first, get first. Book, worst book is equal to books dot get last. All right. There you go. And you're done. Did you have to write your own? I mean, we were looping over this just to see them, but did you have to write your own function that compared all of the ratings and, oh, this one's higher than that one, so I'll update this. This one's lower than that one, so I'll update this. Yeah, you did that, or
Yeah.
did you want to do that now that you've seen this though?
No.
Yep. This is so much better. Searching and sorting, right? All right. How would we do the oldest book, the newest book? I'm going to steal a lot of this code. You shouldn't copy pasta, but we're doing it. By year. There we go. And instead of the rating, what should we get? Get publication year. Capital Y. And I don't know if we want to reverse it or not, because if I don't reverse it, what's the natural ordering? Ascending. So the oldest book is going to be up here. The newest book is going to be down here. So oldest, and newest. So I have to copy paste my loops? Nope, just created a new comparator. And make sure that you're using it, by the way. That's the danger of copy pasta, right? I changed this, but I should have also changed this. Right? And also, let's put in a separator here, system.out.println. Come on. Well, we just need some white space. Oh, here, I like putting in separators. You can get nice and fancy with your ASCII art if you really want to, but you don't have to. Right. All right, let's run that one more time and see if we get it in there. 1852. That's certainly going to be one of the oldest books in this collection here. The newest book is Sure I'll Join Your Cult by Maria Bamford there in 2023. Surely there are ties here. There. Two things that were published in 2011. How do you know which one goes first? Which one should go first? I don't know, I don't care, right? If you want to have that finer granularity of control, you can do something like this. Sort by author, then by date, right? Okay? So what I mean by that is I want all the Frank Baum books together. They are all together, by the way, just by virtue of them being so damn old. I don't have any other books that are that old, right? But let's look, there's Terry Pratchett, but that's because they were published very close together. No, Murakami is together too. Right, that just happens to be a nice coincidence, right? So let's sort by author. In other words, Anderson will be up here, and then Zoe will be down here. But then for the same author, I want it in order, in temporal order here. And that looks like that's what it is here, but that again, that's not necessarily why, right? So let's go ahead and steal some code here. Right? CMP book by author, then year. Right? For that, I'm going to go to the next line here because I don't like long lines. So first of all, we're going to compare the author. Get author. And we run into a problem immediately because it is not compiling. Right? Why is it not compiling? The type book does not define get author T that is applicable here. It's really, really cryptic message. The problem is we do not know how to order authors. Let me come over here to that person class. And an author is a person, right? Do you see anything in here that's saying it should be by first name or last name? Or let's go ahead and update it so that there's a social security number. It should be, you should order people by their social security number. Or if they're students, you should order them by their GPA, which would be a double, right? So I'm going to add that here. And here's one way of doing it. There are several ways of doing it, but this is the easiest way. This is going to be implements comparable, right? And a person is comparable to another person. Apples to apples, oranges to oranges. I could do something like this. That doesn't make any sense. You're comparing a string to a person and a person to a string. A string is not a person, and a person is not a string. So I'm going to compare apples to apples. Person is comparable to a person. Now that's complaining because I have not, what's wrong? Come on. Must implement, yeah, there we go. That's what I want. Add unimplemented method. Compare to. I'm going to compare this person to that person, right? I do the same idea here, that it's going to return an integer. It's going to return something negative, positive, or zero, depending on the relative ordering of those two people, right? The way that I'm going to do it is by last name, then by first name. Right? So int result is equal to this dot last name dot compare to that dot last name. All right. Now, if they have the same name, what value will be stored in result right now? Smith and Smith. It'd be what? Zero, right? So if it's 0, we need to disambiguate it by looking at the first name. Compare the first name because they have the same last name. Right? So result is equal to this dot first name dot compare to that dot first name. Right? And return result. Now what if they have the same last name and the same first name? Then as far as our data is concerned, they're the same person. Right? Come back over to book demo, and what has magically happened? It's now comparable. Right? Then comparing book get publication year. There. So did you see that chain there? I want a comparator. Comparing the author. If they're the same author, then you start comparing the publication year. Right? And if you want to reverse that, you can. Dot reversed. Or if you want to say reverse the authors, dot reversed, then not reverse that one. Right? You can chain these things as many times as you want. So this will be the authors, where now Z's are up here and A's are down here because I've reversed the authors. And then all the authors are together, and the publication year will be in the natural order, in ascending order. So oldest to newest. If I sort this, we go ahead and grab this, put it there, and use this comparator to sort. Let's look at that one more time. The Dying Earth by Jack Vance, V, right? That's going to come first. Then way down here, we've got Bamford, B. Right? It's going to be in order, according to the author, in descending order, reversed order. But now let's find Haruki Murakami there. There we go. Oh, we've got three books there. Excellent. And the oldest one is in 1982, then 2014, then 2017. Did I have to do a lot of code writing here at all? All I had to do was chain these things together. Right? And you can chain as many things as you want, right? Do it by that, then by that, then by that, then by that. You've probably seen this before. If you go in Excel and you want to sort a column, right? You can go to sort, and then it brings up this dialog, and then you say sort by, and then you select one of the columns. And then you can have this plus button over here that says then by this column, then by this column, and you can do that as many times as you want. Right? Same idea here with a comparator. Okay? All right. Excellent. Let's find a book or all books by Haruki Murakami. Right? So how would you go about doing that? Let's go ahead and go with a book for now. A book by Haruki Murakami. So my first instinct would be to sort it by the author, and then go through, and that's not Frank L. Baum, nope. Frank L. Baum, nope. Maria Bamford, nope, 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 and then until you find the first one with Haruki Murakami. Right? I'm not going to do that though, because like I said, I don't like writing code. Right? I hope you don't like writing code either. Let's go ahead and do it by author. Right. There we go. We don't care about years. Right. Then you sort it by author. Then what I'm going to do is I'm going to search it by author. And I'm going to show you the best way of doing it. Collections.binary search. I'm going to search books for a key using this comparator right here. Right. Now what I need here is a key. Before we do that, let's understand what binary search is. Let me grab this as an example. Yeah, let's go ahead and grab this as an example. Right. Now, suppose that you wanted to search through this for, say, 0. What would you have to do? Start at the beginning. 5, that ain't 0. 3, that ain't 0. 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 That is 0. We're done. Right? It's called linear search. You start at the beginning and you go all the way to the end until you find what you're looking for. You're finding a needle in your haystack. Remember that we sorted this, which would be 0, 1, 2, 3, 5, 5, 6, 8, 9? Yeah, that looks right. Right? Now, I want to search for 0. Well, if I did the same technique, what would happen? I'd get lucky and I'd find it in the first one. What if I were searching for 9, though? Now, I'd be really unlucky because it'd be at the very last one. So I'm going to hedge my luck here. And because it's sorted, I'm not going to look at the first, I'm not going to look at the last, I'm going to look at the middle. Right? Suppose that we're search for 9. Right? I'm going to look in the middle, 5. And I know that it's sorted. So if 9 exists in this array, where would it be? On that side. Right? On this side right here. Right? Do I even have to bother looking at anything over here? Nope. So effectively, I've cut out half of the collection. Right? Repeat. Look at the middle element. Now, they're an even number here, so there's no middle element. So let's just look at 8. Right? 8 is not 9. So, therefore, where should 9 be? On that side again. I've effectively cut out that much now. And I've only made 2 comparisons so far. Right? My next iteration here, where do I find it? Find it right there. That's called binary search. Okay? And it only works if it's sorted. Okay? So, what I need to do is I need to sort it. I have. Then I'll use binary search on the same comparator. But what I need is a key here. Okay? Now, apples to apples, oranges to oranges, books to books, and people to people. I am searching for this particular author here, Haruki Murakami. Let me make it something. Person, author, or let's call him what he is. Murakami is equal to new person. Haruki Murakami. All right, there we go. Let me try searching for that person right here. It's not going to compile. Let me ask you why. Well, let me walk you through why. What is books? It's a list of books. What is this a comparator for? It's a comparator for books. What is this a key value here for? Person. Is that apples to apples? Books to books? People to people? Nope. So I need a Murakami book. Person, or not, book. This is called a key. I'll call it Murakami key, right? It's just, it's a book instance where only the author is set. The rest of that stuff we don't care about. We don't care about the title. We don't care about the rating because we're trying to find a Murakami book. Right? We don't care about that other data. So new book with just Murakami. Right? Doesn't compile there now. Why? Is there a constructor that only takes an author, a person? Nope. So what should you do? Make one, right?
So you have to have a constructor for the kind of instance.
Anytime you're going to use it, yeah, make one. Right? And again, it's not a lot of typing. It's just generate constructor using fields, deselect all, and I'm only interested in the author. There we go. And like any good programmer, when you don't want to do something immediately, clean this constructor up. Right? You put in a to-do. Why do we do that in our IDEs? Because it shows up over here in the task list. That you can double click on this. It looks like I've got something else in another project over there. Oh, yeah, there was my demo from yesterday. I also didn't want to do it that day. So I said, to-do, I'll do it later. Right? But you always remind yourself about it. Leave a note, right, so that you don't forget. And you have to, it's just a single line comment, all caps, to-do, and it automatically gets aggregated here in this task list. Okay? All right. Come back over here to book demo. Now I've got a list of books, a comparator for books, and a book. Apples to apples, oranges to oranges. Let's run this. I don't know if it was successful or not because it actually returns an index at which you can find it. Right? Book, Murakami book is equal to books.get the book at that index. And let's print it out to see if we actually got a Murakami book. There. So did we get a Murakami book? Yep. We got the one from 1982, right? I don't want the one from 1982. What I want to do now is I want all books by Haruki Murakami. In fact, I'm going to get greedy. I want all books by all organized by all authors. Right? Why limit myself to just this one guy? Right? I want a library where I can say Frank L. Baum, and it gives me those 4 books that were there. Right? Maria Bamford, and it gives me that 1 book by her. Right? So, I want to solve this problem once and for all, so that you quit asking me about these single authors over there. Okay? Data structure ideas. Remember, one of the mantras of this course is smart data structures and dumb code are a lot better than the other way around. What kind of data structure could I use to bring here? It's bare here. I heard it at the beginning. What would we be mapping? An author to all of their books. Emphasis on the S there. So an author will be mapped to a list of books. And an author is a person. So let me make that map. Person to a list of books. Author to books is equal to new hash map. Okay. Now I just have to create that. So let's outline this. For each book, find the get the author, right? Use the author to find their list of books. Right? Add their book, right, to the list. I'm going to use the person. It's going to map to a list of books, and I'm going to be able to add that book to that list. Careful though. What if no such list exists? Then go ahead and create it. Okay? For each book. That's just a for loop. We've done that, right? In fact, we did it right here. Anytime we printed all this stuff out, for each book. Right? For each book. Right? And let's go ahead and indent this stuff. Get the author. Right? Person author is equal to b.getAuthor. Because we invested all that time up front in designing that book class and designing that author class, all these things are now free to me to use. I've got the author now for free. Right? Use the author to find the list of books. Right? I want their list of books, or author's books. Author books, I'll say, right? Have you heard the mantra that there are only two difficult things in computer science? One is cache invalidation, and that's difficult. The second is naming things. Right? So, author books. Okay, that's good enough. Right, move on. Right? Author to books.get the author. Right? I'm got the author, that's my key. The author to books is a map that is now giving me this list of books here that I'm calling author books. Right? There. Oops, move that up. Use the author to find their list of books. Now I've got it. What if it doesn't exist? So how will I know that if it doesn't exist? How do I use a map? I ask it for a key. Give me that thing. I don't have it, so I'll return it. Nothing. What is nothing in Java? Null. Right? Same as in C. Nothing is null. Right? So what if it doesn't exist? Create it. So author books, author books is equal to new array list. There's nothing in it, by the way. It's just an empty list. But now, in either case, it exists. Either it existed before or it exists now. In either case, I can add that book, B, author books.add. Yeah, there we go. And then put it back into, the map. Right? So what is it? Author books dot put author is going to map to their author books. There. Okay. Now I'm not going to do it, but generally what you would do is you'd go back and you would clean up. Make sure that you don't leave that cruft in there. I'm going to leave it because I think it might be valuable in the notes. Okay. And then system.out.println author books. Author two books. Again, naming things is hard. There we go. All right. Morrison, Tony, now maps to her one book that I've got, and the only book that I've read of hers. Jones, Diane Wynn, Howl's Moving Castle, and is it one? No, that's it. Okay, there we go. It's not very, it doesn't look very nice, but here, there, Frank L. Baum, he's got 4 books, right? Wizard of Oz #1. Oh, he should have more books. All right, there's a bug. All right, where is it? So if it's null, we create it, we add it to the book, and then we put it back in there. I'm not sure. maybe I'm missing something. Let's go ahead and, we've got 5 minutes left, so let's go ahead and go for, what it would be, person, author, in the collection, author to books dot key set. So I'm going to iterate over all the key sets, and what I'm going to do is system.out.println author, and then I'm going to, for book B, in author to books dot get author. For each book, I'm going to system.out.println a tab over and then B. I'm going to make it look a little bit prettier, is what I'm trying to say. Right. And I am sure that there's something wrong here, because I swear that there were more than one Frank L. Baum books, right? Okay. And it looks like everybody only has one book here.
Almost, yeah, it's one at a time, but I see one here.
Ah, okay.
I've seen four, just four on this list.
There we go.
They're not together.
They're not all together, all right? So I don't know if we have time to solve this problem. I mean, we have time to solve this problem, but I don't have time to explain why it's happening. But I'll show you how to solve it. Another thing that you should do with all of your classes is generate hash code and equals methods, right? And it should be based on the entire state of your classes, right? Yeah, whatever, right? There, equals and hash code. Also for the person, source, generate equals and hash code and equals based on first name and last name, right? Now let me come over here and show you that it magically works now. Haruki Murakami has 3 books. Where's Frank L. Baum? Oh, there are 5. Wow, I've got 1 through 5 there. There are actually like 16 books or something that he wrote. Then his family took it over. It was a cash cow for them. Right? Anyway, why did it work? We are using a data structure that uses what's called a hash, right? A hash map. And for that to work, we have to have a hash code method. We also need an equals method that says that this object is equal if the first name and the last name are equal. Right? It is different than what we did before with compare to. That only compares them and says that this one goes before, or that they're out of order, or that they're equal with respect to this comparison right here. But the hash map does not use that. The hash map does not use this compare to method. It uses hash code and equals instead, which are always built in. By default, it'll be based on the memory address of the author, right? Rather than their first name, last name, or the memory address of the book instead of its title, its ISBN, whatever, right? So as a consequence, you need to overload and rewrite this hash code and equals method. Don't worry, it's done for you by simply clicking a button, right? You don't have to worry about the details. But there, have I solved all the problems? Now you can get them by the author. I could separate them all by year. Give me all the books that were published in 2021, right? I could have another map that maps the year to each one of those books, right? I could do a lot of powerful stuff with a map now that I've got all of the building blocks, the lower level stuff, like the book class and the person class. As you are finishing up your first assignment for this Friday, right, and working on it, think of ways to do this, right? Think of ways of leveraging searching and sorting, right? You have to find what was the highest elevation that I ran at? What was the lowest elevation that I ran at? How are you going to do it now? Searching and sorting, right? Sort it by the elevation. But to do that, you need something like a book class. You need a run data point class or something like that, okay? But otherwise, you pretty much have everything that you need right now to complete that third assignment. Or the first assignment, excuse me, the third exercise. Yeah?
Is there any way to have it due on Saturday?
Why is that?
I have lunchtime on Saturday, not a lot of time this week.
We could talk, yeah. All right. All right, so I'll see you up in lab today.